In today's class, I will start from rigid motion. Okay, we already studied a rigid body in your first year or second year in the university, right? And defining the rigid motion is the rigid body motion. So what is a rigid body? The definition of a rigid body is it will not be deformed at all. So it's not a reasonable assumption, but in the kinematics or in the dynamics derivation or 推导, sometimes we need to start from the rigid body motion as a start point, because if because in the nature life, we always have a flexible material. Although we think the steel, like a steel, is a very high stress material, but eventually it will deform. Just we cannot see from the bare eyes, but we can observe the deformation from the like a microscope. Yeah. So we have the material test. If you do the material test, you will find out, oh, there's some wear out. The wear out is sometimes can be defined as one deformation, and the deformation cannot stick on the material anymore, so it peel out. Okay, but in our case, it's not so complicated. So enjoy the class today. Yeah, we will see what's going on. I think I will stay in the mode for the PowerPoint, then I can write something before we touch the important part. Okay, so I believe I deliver the chapter 2 to you guys. Hopefully, I hope you guys can do the preview, and please do, because if you have the preview work, then it will be easier. You can understand what I'm talking about and what's going on, and it will be easier. And just remember, we will have a test, a midterm test, before we invite the outside speaker come to our class to deliver 2 speeches for you guys. So remember the very fundamental geometry transformation, then you will be fine. Okay, and then later on, so after the midterm exam, I will say will exactly on the midterm week. Okay, so before that, I will finish the forward and backward kinematics introduction, and after the midterm exam, then we will have 2 weeks for the outside speaker, and the speakers will finish their speech. Then you will go to the practical. I will not say training, practical activity. Okay, so you can actually manipulate the robot by yourself. Okay, so today's rigid motion. The chapter for me is okay. Maybe we can start for this part. Okay, as we mentioned, because there's one student that asked me, is possible one machine can use only one coordinate to describe it. How about that? Yeah, because before, I think you step into the more graduate level class, yes, it is possible, because we always discuss about one particle or several link. So use one coordinate will be fine. But in our case, especially for the multi-degree of freedom mechanism, it is very complicated if you use only one global coordinate. So we will introduce the idea is we use the various coordinate frames to represent the position for our mechanism. And then not only the position, including the orientation. As we mentioned last week, in space, we have a 6 degrees of freedom. So not only we reach the point, when I use my finger reach to the point, but how is the orientation is still have a 3 degrees of freedom. Point to somewhere, this depends on the orientation. So it is quite of, if you go through the whole class, I think you will be fine. you will be realize, oh, this is not too difficult, I would say. Okay, so I would say over here we need to learn because we have a lot of reference coordinates, right? So we need to convert back to the global coordinates one by one. And if we do that, the calculation will become very easy. And yeah, come back to the question in the beginning. Then why don't we just use one global coordinate? Okay, so it is a kind of contradictory argument. But when you do that, you do the mathematics calculation, you will very appreciate it because you set up the coordinates at each joint. And each joint can reflect back to the global will be easier. But if you just use the global to point to somewhere, then will be the formulation will become very complicated. It's very difficult to solve. You will see later on. Okay. So over here today, we I think we start from the I would say position vector. Okay. I'm not sure. I think the vector in the mathematics engineer you already learned, but I think the fundamental idea is the same. It's the same. And later on in this chapter, we will introduce the very important Euler system. The Euler, you heard this name a lot. Yeah, if you have interest, like I'm teaching for several years, then I looking into, who is the Euler? Because we always introduce the Newton. We're so familiar with Newton. We always know the Newton about the apple, hit his head. And there's a joke, that is how come there's no this kind of scientist or the physics guy in Asia? Have you heard this joke before? Why they always show in Europe, European country? Why? Newton is come from England, right? But how come we don't have this kind of physics in Asia? Indonesia, in India, something like that. Okay, so there's a joke is because he hit by an apple, but in Asia he may be hit by a durian. Do you know the durian? Leodian. He hit to death. Okay, so there is no chance he come out of idea. So yeah, you may understand my joke later on. Okay, so. For the gravity, is we will not touch the gravity in this class so far. But for the second session, for the dynamics and the control part, then we need to consider about the gravity. But for this session, only the kinematics. I will stop here is to describe a little bit about. When I mention two important quantity, they call kinematics. The kinematics represent only, actually they only describe, not present, describe about the position, velocity, and the acceleration. Okay, but how about in Taiwanese, in Chinese we translate to 运动学, okay? So you learn a lot of 运动学, okay, and you also learn the dynamics. Remember, put X. The dynamics concern the physics quantity in more, including the force or torque. Yeah, sometimes torque is quite different with force. Okay, so. Over here, we only discuss about the kinematics only, yeah, because we need to know the position before we do the control. But it's unnatural. I would say it's unnatural. So everything go until this far, you will see, the AI seems come popular than before because of the computation. But when you look back to the history, it will be a ridiculous stuff. You may know, because if you may not know, but you can observe your friend's baby. You don't have a baby right now. When we are as a very baby or very young, unaged period, we always use our hand to grab something. Is not stable, is not accurate, is not be calculated. Okay, so we can grasp anything. We don't need to know the position, right? We only feel the tactile. Our feet, our tactile is 触觉. We only feel our the grabbing force. Okay, so it's upside down because the nature, like our human being developing, is completely different from our technology right now. So we go to AI, is existing in our world already. We just invented, use the machine to do the human job, okay? So the geometry in 3-dimension space, okay, and including the rotation and the translation also. For the first, I always say the chapter is, I am always not satisfied the chapter arrangement for the textbook. So this is the first session for this chapter. So I will skip this and until we teach the more detail later on. Okay, you can see I spend some times to derive a lot of stuff. Yeah, then I will let you know later on because the textbook did not describe too much. And I think I will go to this part. Okay. Okay, I think this one is good one for me to start from, okay? You already learned, but maybe not with different friends discussion. Okay, if you need to discuss in several friends, several coordinates together, then you need to know some basic rule, okay? The coordinates between coordinates, okay, then I need to draw in something, okay. Assume you already know what is the coordinate, okay? And I have a very simple one here, and I better name it as a 0. So they call frame 1. And there is a position, there is a dot, there is a location I really want to know, and equal P0. And I can have the position vector. Okay, P0 equal V0. Okay, I don't use the upscale. Yeah, okay, I just put the V0. So you know the V represents for vector. Okay, and that will be fine. You already finished that. But if you need to use the other coordinate to describe it, same point. Can you do that? Sure, you can do that, right? Yeah, because you just observe. Always think about this because for the further dynamics also have this kind of concept. The coordinate is where you sit, where you observe to. So you sit on the origin, 原点 origin. So you observe everything. So we always have a example. That is, you take the high-speed rail, and you pass the Taichung station. People in Taichung station, they look at you, and you just pass by and go away. So I am the observer, and I am the coordinator origin, and I observe you, and I can do the calculation for the position. Oh, go very near and far away. Okay, so there's no problem. The problem is if I need to use, okay, let me go to another drawing. So a robot, okay, this is my robot, okay. Then the robot can do the same. So we will attach the coordinates onto the robot. Okay. For example, I use a different color here. X0, Y0. It's okay? of course it's okay. And I attach the coordinate, the next coordinate, 2, should be 2. 2. Agree? There's no problem, right? Okay. And the previous people the Asian people, they spend a lot of time because they don't have computer, but they have a lot of time. So the time is their computer. So they set up the coordinates on the multi-degree of freedom mechanism. But if you set up by this way, it's easy for us to observe. But when you derive the equation, then it will become very difficult. Because I set up the frame 1 and frame 2 in purpose in an easy way. The easy way is I always perpendicular to, or I always parallel, the x-axis, always parallel to the ground. It's easy to observe. But when you do the rotation, we do the motion, then it will become very difficult. Yeah, because it cannot describe the link posture, 姿态. You cannot describe the posture for each link. When I move to somewhere, if I set up the coordinate by this way, then the coordinate is useless. Yeah, because I cannot identify what angle it already turned or it already maintained. So for this kind of setup, is wrong. It's difficult for us to do something else. So we better have a more realistic way. So in the future, we always do that. We need to align our arm, because we assume our arm is rigid, right? If it is flexible, there will be another story. But if it is rigid, then will be makes sense. We set up one of the coordinates, not necessarily x1, maybe y1 is okay, depends on you. Okay, so you need to set up one coordinate can describe the rotation of our arm. The rotation is not observed from the joint here. The rotation is observed from some important joint you want to reflect back. Okay, so in this case, x0, y0 is our, we call global coordinate. The other is called reference. Okay, coordinates, because we have a lot. Okay, there's only one global coordinate. So we need to calculate each position in space back to the global. But before we do that, we can use the reference coordinate to do a lot of stuff. Like we can rotate locally. We can, if your joint is prismatic, it can stretch out, stretch back, and you can do a lot of stuff. And it will be easier. In the future, you do the control section. Yeah, because you really need to know how far I can reach, and did I reach the final position yet? If I don't know that, okay, this is another I would say a chapter. But I would say over here, I just want you to build up the idea for the reference coordinates. Is we need to set up the reference point at each joint. Okay. Then we can do the calculation. But we need to have this kind of concept before we step into the lousy calculation. Got it? Question? Any question? It seems a little bit doubt somewhere. Understand what I'm saying? Okay. I'm thinking about I put a video, YouTube, then you can click on to rewind back, to see what I'm saying. Yeah, it's a good part. Okay. But for this class, I need to require a video. Okay. So if there's no further question, then let's go to, or I say let's roll, okay? Because the sequence, I change it a little bit. We go back the complicated case later on, okay? So in order to present the position is a relative position. It's not absolute. The opposite word for the relative is called absolute position. Only global coordinate have the absolute position and the orientation. The others is called relative position and orientation. For one rigid body, for one another, we attach. Okay, the attached coordinate is called reference coordinate. I call it reference coordinate, but there are different names. But you use one is okay. Everyone can understand. Okay, and yep. Let's go to the case will be easier. So in our engineering study is so great because we have a lot of figures can observe. Okay. So over here is a very simple. They call. Did I mention anything here? What is the operation? What is the operation over there? It's called inner product. 内积. Okay. Inner product. Okay. So just in case you are so confused, okay. As I mentioned, why I need to describe the link rotation? Well, I know the position will be fine. How about, I don't care about rotation. Of course, you know why, okay? So over here, I just want to show you the very fundamental one. If there is a coordinate and it rotates with the angle, you will see what's going on. Because if the coordinate is a unit, we call unit length, unit vector, so it's 1. So you need to 1 cross cosine. So the new position over here, I explain this later. Okay, this is x0 and it rotated to x1. So where is the coordinate? This is x, this is y. Then you will become 1 multiplied by cosine theta. The other is 1 multiplied by sine theta. It's an easy one. Any question for this one? It's okay if you don't quite understand this part. Come to me after class because I think I assume you guys already know the geometry. Okay, so we have a 1 vector. Okay, and what is this one? Okay, I need to define this one by writing. Put it on your note, or you will forget tomorrow. He don't like my 0. Okay, friend 0. Later on, we will have a very similar representation for each parameters. The lower case represent which one? x1, x2, x3 is okay. But if it did not describe anymore, for example, the uppercase, nothing. It just have a 1 coordinate, it should be okay. But if not, because we will have a lot of coordinates, so you will refer back to which coordinates. In this case, it's friend 0. When I say friend 0 is the O0, X0, Y0, they call friend 0. So it's easier to write. So I will put it this way in our class. So try to understand. Okay, and question? So it means when I do the rotation, the original x1, not original, the new x1 need to be defined in the friend 0. So you need to tell me, oh, what is the x vector, y vector from I observe from frame 0 to x1. It's lousy, right? But if you know the mathematics, you will understand what I'm saying, because I try to describe the formula. You know, describe formula is very difficult, right? Okay, so it's a cosine theta and sine theta. The other one is y0. Okay, well, no, sorry, y1 is y1. So refer back to the frame 0, same. Is minus sine theta and the cosine theta. So you exactly know where did it come from, right? No worry, right? Okay, so if you know the inner product and this is the unit vector, so there's no amplitude in the front, so only left the triangle part, and then you'll be fine. And combine it together, that's the magical term. Okay, so this is the x1 line, this is the y1, I should not say line, it's a column. Okay, the horizontal matrix is called row. Okay, I write it down. Okay, row and column, I don't memorize this stuff, but for a long time, okay, you already engraved in your mind. So right now I can memorize out. Okay, so combine these two vectors together. Remember, this is a vector. This is a vector. So when I align with this vector, you will become a full matrix. And the full matrix over here, it represents a rotation matrix. So this is a very important matrix we will use in this class. So try to understand where did it come, what did it mean, how will we use, okay? So this rotation matrix will follow us. So just, okay, let me do the operation. A little bit, huh? Rotational matrix. When I say it is a rotation matrix, you need to know what is the operation between matrices. Okay, so when I do that, for example, I have a position. Maybe I say, oh, okay, I just mentioned, this is, okay, got it. 1, 2, not 2, 1. 1 equal to R0 and 0, Y0. Should be, I know the position. I know the position, but what should I rotate? I should give you a good example. But eventually, with this rotation matrix, you can convert any, if you have an angle, yeah, you know the, yeah, so, okay, at this point, you know the rotating angle and the position, then you can rotate it to whatever you want. Okay, or you need to find out what is the rotating angle. Okay, should be 0. Yeah, should be 0. P0x, P0y, then become P1x, P1y, P1y. Okay, then become this one is more reasonable because later on there's just coordinate. Okay, so you can convert between two different coordinates. Depends on what is the angle it rotates. Okay. Let's just describe more details. So have the handbook, the handwrite, not handwrite. I have the partial copy of the textbook. Okay. Actually, yeah, I purchased some of this textbook. Last semester, I treat it as a gift to the highest grade students. Yeah, because I know purchase the textbook is sometimes difficulty for you guys. Okay, so I think I purchased 6 and they give me one for free, and so I have several one. Yeah. So as I upload to the internet, it's not legal, so don't distribute it to anyone. Before I just pass to the TA and you can receive the copy from TA. I should not do that because I do the recording. Okay, so anyway, just try to read your reading assignment, okay? And they have every detail in your text. I already distributed to you. So over here, it just describe more detail about, oh, how can we do that? Because we use the inner product, as I mentioned, okay, over here. And yeah, eventually they have some kind of they call operation relationship. But because we are symmetric matrix, there's no problem at all. We only care about some matrix is not symmetric. So the symmetric can do the transpose T. We can do the inverse. Okay. Do you still remember how can you do that? That's good. That's good. Very good. Okay. But later on we will use MATLAB. Yeah, MATLAB is a very good tool. Okay. So in the exam, maybe I will ask you to write a rotation matrix to do something else. Then you are allowed to use the computer over here. Yeah, then we can have your, you don't need to do the lousy computation. Then you can use the MATLAB to do the calculation for you. Okay. Okay, so before we go to the projection for 3 dimension, I think we go too quickly. Then I think we can go back to discuss about the question they provide in the textbook. And this is a good one. Not good one, I just want to solve. You know, in sometimes I heard a lot of students mention, I don't have interest in this part. I don't have interest in this field. But I review back to what I'm studied before. That is, when you see the description for this question, you will get angry in the textbook. Why? He only give you the vector and the answer. There is no procedure. Will you not get angry? So I'm thinking I need to solve to see what's going on. And interesting, it's interesting because for the vision 1, the answer is correct. For the vision 2, this one, the answer is not completely correct. So it's weird, okay. But over here, I show you the problem in vision 2, okay, as I distributed to you for the material. Okay, in a space, there are 2 coordinates. There are 2 coordinates. The first coordinate is called 0, frame 0. I call it frame 0, okay? The other one, I call it a frame 1, okay? But frame 1 has a rotate a little bit for the angle. It did not mention that. I think it mentioned somewhere, I forgot, for 45 degree. Okay, 45 degree. Okay, they already give you the information over here. I just want to check it out. Okay, originally they give you, oh, I have a position P. Okay, actually the P0 and P1 is the same point in space. But as I mentioned, the upper scale, what does it mean for upper scale? P0 means, P0 stands for I observe from frame 0. The P upscale 1 represents I observe from frame 1. Same point. Okay? So at this point you will understand, oh, it's, I don't know. How about you? I'm thinking, oh, that's quite interesting. Okay, so when I observe for P, the coordinate is 5, 6. But if I observe from the frame 1, it's some translation between the frame 0 and the 1 rotation. So you will see it's a little bit different. So it's a -3 and 3. This is a vector, okay. And I think they provide you the information for, or it's not be calculated, okay. They provide for the O10 and the O01. What the hell? Okay. When we read this kind of vector, we always start from the lower case. Okay. So it's O10 and O01. Okay. I think we need to define what's that. Okay. I think I mark for a part. Okay. For the upper scale, we represent the frame. Okay, so O1, I don't say lower class. Okay, low O1, that's O, not 0. O1 represents the origin, 原点 for frame 1. O0 represent the origin for frame 0. Okay. But they refer back to each other. They have this relationship. Okay. So this is the result. Okay. Oh, they told you if I observe the frame 1 from here. Oh, I forgot. I have a gift for you. Because you cannot write such accurate figures like me. So this is the gift for you. But if you want to write the very precise one, I suggest you use the PowerPoint. Will be easier because the handwrite is difficult, I would say. So write everything you want down, and then we start to write a straight line, the straight vector. So the concept here is we just want to figure out what is the vector come from, I would say. And there is, okay, there's a V1. Okay, I saw the V1. Vector 1, vector 2, something like that. Okay. Okay, the vector can be moved parallel. Just don't turn. What is vector? Vector, it means the direction is important. But where do I start is fine. I rephrase again. The vector is you need to maintain the direction and the magnitude. 大小, direction and magnitude. But where did it start? Not important. So when I say V11, vector 1 to frame 1 is I need to move to frame 1. V11. Agree? Okay. So if you have this concept, then you will be fine. Okay. The other V20, V21, same concept. Okay. Let's go to next step. So over here, I do a lot of drawing and to figure out what's going on over here. So that you can take a look. So I know where is the vector 1 and vector 2, and this is not vector 2 actually. Okay. So okay. The very fundamental one is I know the position. I know the position because I have a 6.5 or 5.6 for P, and observe from frame 0 and frame 1 is different. It's the 3, minus 3 and 3. Because it is rotated. So if I want to refer back to whatever I want, I need to rotate whatever it rotates back to everyone is parallel. Okay, I need to explain a little bit more detail in Chinese. Okay, 所有已经旋转过的，一定要把它通通旋转回来，不然没办法做坐标，或者是坐标的移动，坐标的 move，因为你没办法讨论，所以记得在运算中一定要把它转回来。OK，so we can see the first rectangle. What is the P0 and P1? No doubt, the textbook give us. So how can you obtain the number over here? I just want to describe it. Okay, so over here I have. Okay, I start from the rotation, rotating one. Okay, so I already have a final result -3 and 3, and I want to know if I rotate the frame 1 back to the normal. What is normal? Is parallel to the original frame 0. Then what is the coordinates? What is the coordinates? Because if I can rotate back, then I can do the later on calculation. But I need to rotate back. So when I rotate back, I obtain the x2 and y2 to have the number minus 4.24, something like that. And I define it as, I think the V2 over here don't make sense. Huh? Oh, okay, yes, V2. It's V2 over here, but it's not original V2, right? I observe from the frame 1 and, okay, P2, okay, sorry, okay, one more time. Frame 0, frame 1 is the tilt 1. Then I move the tilt 1 back to the frame 2. So I define frame 2 over there. Okay, so if I observe from the frame 2, the position for P is the coordinates. The position for P in frame 1, what is the coordinate? -3 3，合理吗？他给的，但是我想要把它转成跟 frame 0平行，所以我要转45度回来。其实那个真的好像不是45度，45度回来。那这个时候我转回来之后，我叫它 frame 2。我这边标了嘛，我标了一个非常漂亮的浅蓝色的那个 frame over there，OK。那从这个 frame 2来观察 P 的话，它的坐标-4.240，有一点点不精准。你看那个图，因为那个图看起来明显它 y 不会是0啊，一点点不精准。你看它有点 tilt， 有点斜斜的。我只是把它转回来而已，这好像不是水平的，但是计算上是这样，计算，所以我才说这算出来不是很准，但是是它的数字的问题。我就说在第一个版本，我用同样的方法算，完全正确，完全正确，但是跟你们分享一下，就是你要把它转回来，算正的，算不转45度的，那个坐标在 P 的话是-4.2，第一个你要先知道。那这4.2呢 is for vector V2，我们看第一页的啊。第一页的 V10 跟 V11，那 V11是82，是对第一个 frame 啊。现在我已经不是对第一个 frame 了，就不管它了。所以呢，我直接呢，其实我这边应该要严谨一点，这个叫做好，每次写都有东西可以改。OK，is called V 2 1 2，我看一下哈，1 0 1 1 1 2。1 2，它不是 exactly V2 是我标的，所以它是一个 V12。先停在这里，把它看懂。我看到同学已经有人知道我在讲什么。OK， 把你们讲到你们听懂，是我最大的成就。听不懂，就不好玩了。好来 OK， 所以这边的符号稍微有点 mix 掉所以我来把它到时候再调整一下来 ，the vector v1 在我们前面就是 v10 v10 我现在是有一个 v12 了那其实这个是加那个 v10 跟 v12 跟 v12， 这是我们向量的闭合。OK， 我的 vector 的方向，那我就可以求出这个 vector 的值。所以这个 vector 的值就是这两点间的值。OK， 所以呢，这两个 vector 相加我这次题目给了，这我算的，加出来是 9.24 跟什么69.24跟6所以我的 O1 0肯定是它O1 0对它的O1 嘛对它的，或者是 O2 对它的O2 O1 跟 O2 不是同一点吗我只是想代表它是同一点。So let's continue a little bit for this session, and later on we will go back to the chapter 1 to finish what we left last week. Okay. So you have already see we just have two frames, and you already see the complex operation between the two frames, and just only one vector. So I believe there is a better tool or the more systematic tool can help us to describe this part. Okay, so over here we just touched this a little bit in the beginning of the class, and that is we use the inner product to come out the rotation matrix. We will utilize this rotation matrix and build up the rotating matrix between each frame. Then we can connect it together. Will be easier for us to do something else. Okay, so if we expand to the three-dimensional, if we use the method we just introduced, then will become a nightmare. Okay, so will be easier part is we do the mathematical vector computation will be easier by this way. So over here, they just want to show you when it rotates in space from the frame 0 to frame 1, it defined. Then we have a rotation matrix easier over there. Okay, so we just mentioned a 2x2. I can show you in the video. So let me go back a little bit. This is a 2x2 rotation matrix. Okay, so where did it come from? You already observed. How can we have the full matrix? That's very similar idea. We can obtain the 3x3, and that will be enough so far. Okay, so if we have a 3x3 matrix, you can describe wherever you sit in space. Okay, for example, there is a rectangle in the figures. So if you can describe it in the frame 0, but if you want to describe in frame 1, the rotation matrix can transfer every point, every vectors, okay, from the rectangles. Okay, so this is the very fundamental concept. Okay, and over here we go more detail because the chapter 2 later on will be more systematic, but over here we still need to build up some very basic concept. For example, when we do the rotation in space, you need to define which axis you want to rotate, or which axis. Okay, you can rotate it with z-axis in this case. In z-axis, you can see from the frame 0 to frame 1, okay, we maintain the z-axis rotate by itself. So only the x and y-axis rotate with specific angle theta. So the previous three-dimensional rotating matrix reduced to this type, R10. So it means I have a rotation. I want to refer back to the original frame 01. Then I use the rotation matrix. Okay, you do the computation, you will find out why. Yeah, because the cross product for the 90 degree is 0. So a lot of column and row become 0 in this case. And yeah, I don't think I need to trace too much, but yeah, just let you understand, oh, if you rotate it with z, then the rotation matrix become this one, this type. Look one more, then you will understand why should I introduce this part. If you rotate it with x-axis, then the 0 goes somewhere, is perpendicular. Perpendicular is called 垂直. Okay, so you will have this type, then you will realize immediately, oh, this is for rotation with x-axis. And of course, the type over here is a rotation, rotate with y-axis. Okay, so yeah, before I have in class and homework say, oh, try to draw something. I like you guys to draw in pen, with pen, not just take picture from the cell phone. But it's trend, right? Everyone memorize everything from the cell phone. Yeah, but still, yeah, if you get boring, yeah, you can draw a little bit. But for the computation, it will be easier. Assume there's a rotation matrix 1, 0, R10. And if you, yeah, we already tried this in the beginning of the class. If you want to transfer some position from frame 1, then the type will be look like this one. Okay, because it's three-dimensional and you have your x, y, z, they call UV W. Okay, UVW. So you can convert the coordinates in frame 1 back to the frame 0. Okay, by this way. So it's a more systematic way. And it's very suited for the huge computation, I would say, because later on you will face a lot of computation work. For the coordinate, if you just rotate with your original axis, would be fine. But if there is a need, you need to rotate with arbitrary axis. So how can you do that? Okay, so over here is one very good case. If there's a vector you want to rotate from vector v to vector 1, then you can put into the theta you want to rotate. Then you can do the rotation for, in this case, for y. Yes, for y. In this case, it's hard to observe what kind of axis it rotates. I just mentioned the rotation R, but I did not mention about the log case. So this is a good one. In this case, I rotate with rotation matrix Y. It means I rotate along with the y-axis. For how many degree of freedom? Is 2 pi? No, pi over 2. Pi over 2, okay. So if you put pi over 2, you know the formula is cosine, negative sine, something like that for the y-axis. Then you multiply it, you bring the angle into the matrix and the vector, then you can rotate along with the y-axis for 90 degree to somewhere you want. then you observe the new vector. You observe the new vector. So in this case, it demonstrates how can we use the matrix, we just mentioned over here, okay? So it's the same one. The one thing I want to share with you is not in this PowerPoint, okay? Because it come out with the Euler angle, okay? Maybe for next week. Okay, so to summarize today's content, I would say the very fundamental vector idea should be built up, and between different frames, the conversion between different frames, we have a tool to do the computation, okay? And for the example I present, they are still have some error, but I think I figure out a little bit what's going on. Maybe I will try. Maybe you can try it for me to see if you can figure out, oh, how can it, because there's textbook, the textbook should not be incorrect answer on the textbook and be published for hundreds of books, right? But I still cannot figure out what's going on, but until now. So maybe you can help me to do that, a little bit, maybe, yep. So, any question for today's introduction, the lecture? Okay. Come here with a casual moved will be fine. But at least memorize something or know something will be easier. Usually I have a in-class homework, or like next week we will have the coding section.